Hey, what's up? Okay, dude. It's like this. You got your game on PS2, on PS1, maybe even on the Dreamcast. You play it with your controller. It sucks. You want to play it with a mouse. Mouse is better. This thing. You fucking see it. So you ask a guy online to make it for you. Uh, but that guy doesn't want to fucking do it. So Stay makes a tutorial so you can do it yourself. That's what this is. Okay, this is a tutorial for making mouse injector hacks. It's going to be a little crash course in the whole process. So you can make the hacks too. It's not that hard, but this will probably be a long video. So if you're low on attention span, then you might want to open up Fortnite on the side while you listen to this. You're gonna get it all just by like osmosis. Okay, so the first thing I'm gonna run through is some prerequisite knowledge that would help. Might not be entirely necessary. Uh, Really, it is. It's pretty easy. Okay. So first, the program is written in C, so knowing C will help. If you know another programming language, then you really don't have to worry because the programming isn't really that extensive. You're not going to have to do anything crazy. So if you don't know C, you know fucking Lua or something, you should be good. You might need to know some basic trigonometry. It's not needed for every hack because they don't. I'm still signed out. Uh, but some do need it. So yeah, you might start doing a thing and be like, "What is sine cosine? What?" You might need to know it. Uh, so okay, next you're gonna need to know some hexadecimal, at least what it is. Do you know what it is? Cause everything in the computer is gonna be in hexadecimal, all the memory. So all the addresses you're gonna find are gonna be in hexadecimal. You're gonna do everything with a calculator, but just a basic knowledge of what it is. If you see a one F, what's that mean? You should know what it means. You're also gonna need to know what memory pointers are. Do you understand the concept of a pointer, of a value that holds an address to a different value? You're gonna need to know that. Okay, and that's everything that you need to know. Programs you need. You're gonna need Cheat Engine to find values. Yeah, you really can't do this without it. So you need Cheat Engine or a similar program. I think Cheat Engine's probably the best one though. The one I use is 7.4 Light Edition because I'm on a diet and it has no adware, I think. I don't know. Also says it has less viruses, or does it? Uh, than the full version. Um, I don't know. They both get flagged for virus, but it's like they're like false positives just because of what the program can do, or are they false positives? So I just used the light version. I don't know. It's up to you. You can put it into virus total and it'll come up. Wow, dude, peeking the mic. You can put it into virus total and it'll come up with like 1,000 fucking viruses it has or says it has. But it should just be because of what the program can do. So it's up to you. You need it if you want to do this, so just download it. It's okay. It's only a few viruses. And then since the program's written in C, you're going to need a C compiler. I would recommend this one right here, Team Deathmatch GCC, because it comes with everything you need. It comes with the compiler, GCC, whatever this is, make, you're going to need that, so it's perfect. Download this right here, click that. I already have it, so I'm not clicking it again. It's just more work I have to do. Okay, and then you're going to need a text editor, and if you're a noob, then I would recommend just getting Notepad++ because it's really light and it's pretty good. So get that too. You're also gonna need the source code because you can't really fucking work on the program if you don't have the source code. So come over to the GitHub and come up to code, hit download zip. That's the easiest way to do it. If you're smarty pants, you can clone the repository. If you know how to do that, then do that. Or make a fork. You can do whatever you want. And that's it. So now that we've got all that set, I'm going to run through the installation of the compiler because it matters where you put it. You got to know where you put it. So I'll run you through it. It's just so you don't mess it up, guy. I'll bring up a little wizard. With this, you want to create an installation, 32 and 64-bit. And now this installation, you can put it anywhere you want. I prefer to put it in C/div, just because I have a bunch of other development stuff in there. You can put it anywhere. You just have to remember where you put it, because you'll have to use it in a second. So install it. Leave all this stuff checked. Make sure this is checked. Add to path so your command prompt can find the program and install it. When it's done, we'll come on back. Okay, it's done. Don't need to read the README, so finish. And now we also have our source code here. We need to extract that. I trust you know how to do that. You'll get all the source code here. You'll notice that there's no executable because we haven't built it yet. We have to build it. So first we need to open up this Makefile in Notepad. And you'll need to change one line in here, and that's this line right here. If this path does not match where you put your compiler, then it won't work. So you need to change that. I think in the one we just did was there. Or no, it's just C. Yeah, it's there. So change it to whatever it is. It has to be the bin folder in your installation. And make sure you put the / on the end too, otherwise it won't work. Okay, next part, we're gonna be actually fucking doing some shit. Looking for the things. So yeah, okay, I lied. First, we're actually gonna test to see if our compiler installation works, and we're gonna build the program just to make sure. So you've changed your Makefile, so come into your source code folder, and if you hold shift and right click, the context menu should include this open PowerShell window here. So you're gonna open that, and a big stupid blue square will pop up. And then you can, to build the program, you need to run make, which is a program. We don't have it. Well, it's because MinGW comes with its own make. It's the same program, different name, but it works the same. So you need to type that in -F, and this was the file option. And the file is Makefile. So this one right here, and then you want to hit enter. You want to hit enter. There you go. It's gonna have a lot of warnings, but they don't matter. They're just warnings, nothing fatal. So let it rock. When it's done, we should have an executable. Might take a while. There you go, it's done. No errors at the end, and boom, we got our executable. And Windows is gonna scan it because Windows doesn't trust anything. It should scan its own files. So eventually it'll pop up. Bam. There's no emulator running, so. Alright, so it works. So now we can continue on to actually starting the hack. Let's go! Okay, now that we've got everything set up, we need a game to hack. So let's go ahead and pick one. I'm gonna pick, for the PS2, Red Faction 2. 222. So you want to go ahead and start her up. Wait for it to load, because it's loading from our disk that we own. And you want to go to the main menu. Okay, once we're on the menu, I like to go to the options and check to see if there's any like auto aim or aim assist, auto look ahead options. There appears to not be any in this game, so we're good on that. Check the controller, nothing. Yeah, technically this game does support keyboard and mouse already, but the mouse sucks. It's not good. It just feels really bad. I don't know if it's just an emulator issue or what, but it don't feel good. I think I'm gonna turn that off too. No invert. Alright, now let's get into the game. Once you're in the game, ignore the tornado siren in the background. You want to get to somewhere where you can just freely move around and there's like nobody's shooting at you, blowing you up. I'm gonna explain what we're gonna be trying to find. So first off, here you got this diagram. It's blindingly bright, but it shows. This is your PC memory. Okay, imagine this is your RAM. You know your memory. And you got all your programs running, you got Steam running, you got Firefox running, and it's using up this big chunk of memory. Firefox would probably be way fucking bigger, but whatever. But then you also have the PCSX2 memory, and it's using a little chunk of itself. What we want to find is within the PCSX2 memory, there is a little chunk that's used for the PS2 RAM, and this correlates directly to the PS2. So this is the PS2 memory within the PCSX2 memory. That's what we're trying to find. And the size is 32 megabytes. If you look it up on Wikipedia, that's how big it is. In hexadecimal, that's 2000000 bytes. So this is what we will be looking for. We want the start of this. We want to look for the start. We want to this right here. We want to find the start of it. And how do we do that? Well, luckily, every PS2 game, while it's running, holds the serial of it, which is a unique serial. which can be found if you go to PCSX2. Just hit escape. This is the serial right down here. You can see this one is SLUS-20442. So that is the serial for Red Faction 2. And that is how we will find the PS2 RAM within the memory. And luckily, 95% of the time, the serial is at this location right here. It'll be at both of these locations. It seems like 95% of the games that I've done, it'll be in both of these locations at 0x90708 and 93390. And this is an offset. Nice peek, bro. And this is an offset from the start of the PS2 RAM. So imagine this is up here is that's 0. Up here in the corner, 0. Brrr, keeps going left to right, and it comes down to here. So this is offset from the start of this. Do you understand? And that's what we will be looking for. And what if it's not at 93390? Well, you can use PCSX2's debugger, and you can search for the value. And you search for this SLUS value, just search, and you'll see it comes up with a lot of them. So here's our 90708. If we double click, we can see this. It's right there. And you'll notice that the serial isn't stored like it's written here. It's actually got an underscore, and then there's a period in between after the third number. So that is the value that you want to look for. You'll notice it's in a lot of other places. Technically, you could use these, but it seems like every game has it right here. And I think this was just like the first value I used, so it's the one I use. And so the actual value I look for is 204.42. And it's actually in 3 locations. But it seems like for 95% of games, it'll be in both of these. So you really just have to notice or take notice of it, because you can use any value. We just need a unique value that is always in RAM. So it's static. It's always there while the game's running. So that's what we're going to look for. Okay, so now we can open up Cheat Engine. Close our little demonstration for now. So in Cheat Engine, you open it up. You want to come up here to select a process to open. And we're doing PCSX2. So select that, hit open. And then over here is where you search for values. You can set up, you can type in a value, blah, 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 blah. You can set the scan type and the value type. And there's also your memory scan options, which we will set up after we find our serial value. So the first search you want to do is for a string. And the string is what we just typed in, 204.42. And you want to hit first scan. And it'll scan for it. And it's counting up. Okay, now you'll notice that there's a lot more than however many, 3 or whatever, that was in the debugger. So which one do you pick? And how do you know it aligns with what's in the debugger? Well, just from doing this a lot, it's generally the first one. So, or it's always the first one. And you'll notice that you have like 07083390 right here, and then you have it again, and then you have it again. This is just like redundancy in the PCSX2 program. Probably for like save states, whatever, internal stuff. I don't know. It just has multiple copies of the PS2's RAM because it's not that big. It's only 32 megabytes. So we want to take the first one, and you can either double click it and it'll add it to the address list, or you can right click add address because that's good for like if you want to select a bunch and add them. Okay, so after that's done, I like to copy this and put it there so I know that's the serial value. And then we know it's at 93390. So how do we get the start? Well, it would be this minus its own value would give you this starting value here, 0. It'd give you the first byte of this chunk of RAM. So, chunk of memory. So we take this value and we open up our calculator. Forgot to show that to you. When you open it, it'll probably be in standard if you've never used it. So you want to come up here, click these, and then click on programmer mode, and then change it to hex, because that's what we're working in. If you do that, come over here, double click the address part in this address list. Whatever part you click will open it. See, you change the type over here. You can change the value. So open up the address, copy this, Control C, and then Control V, paste it in there. And then you want to minus its address to get the start of the PS2 memory. So 93390 will give you the start of the PS2 memory. So I copy this address, add address manually, paste that new address in there, and I just call it start. And then we also want the end of it over here. If that's the beginning, then this is the end, because it comes all the way down, ends there. Technically it's actually here, but because it's the next line. Anyways, so we want the end of it. And then from our little thing, we know that 32 megabytes is this many bytes. So we want to add this value, add this value to the start of RAM. And we have our start is right here. So we just take this value, copy it, paste it in there. It's already in there because we already did that. But we add 2000000. Bam. Now we have the end of the PS2 RAM. So we also add it to the list, and I just call it end. So there we go. We're set up. Do a new scan, and now we can use these as our start and stop for a memory scan, because when you do a scan normally without setting that, you're just scanning all of the PCSX2 memory, which is, this RAM is like way bigger. For demonstration purposes, it would be pretty small. But you're scanning a lot of memory that you don't need to scan. So we just want to scan this little chunk, because that's all we care about. So we take our start, put it in start, take our end and put it in stop. And now when we scan, we only get 3 values. So we're good to go. And then I like to save, I like to save this as its own little thing. Red fraction 2 already exists. No, I haven't done this before, I promise. Okay, so that's saved, and now we can actually start looking for values. Now that we've got that all ready to go, got our start and stop, we can start looking for values. And what values are we looking for, you might ask? Well, when you move in a computer game, when you move the mouse around, you're actually moving the camera around. So It's the camera values that we're going to try to find. And we need two of them in particular. The camera, what we'll call the camera Y value, the up and down. The angle of the camera is what we're looking for. And then the angle of what we'll call the camera X, the left and right. So those are the two values that we need to find. So, how do you find them? Well, you'll come over to Cheat Engine. Now we've got it set up to search just the PS2 RAM. And we're going to want to change the value type to float, because that is generally what they will be stored as for PS2. For older systems, like the PS1, did not have floating point numbers. So for PS1, it'd be stored as just 2 bytes, just a signed integer. But for here, we'll do floats. And to start the scan, you want to do an unknown initial value because we don't know the angle. We're going to start by looking for the camera Y, and we don't know what angle it's at. It could be, and we don't know what scale it's on. It could be in degrees, it could be in radians. We don't know. They could be doing something real weird. Who knows? So, unknown initial value, do a first scan. You'll see it's found. This is basically every value within the 32 megabytes of RAM that we're searching. And then you just want to move the camera. Just move the camera Y a little bit. And then you want to change the scan type to a changed value. You hit changed, and you'll see it went down quite a bit, from 7 million to 48,000. So you want to redo this process, move the camera, changed value. Move the camera, changed value. And you could do this all day. Move camera, change value, move camera, change value. Or next scan, move the camera, next scan. But you see it's not going down as fast as it did before. Just because there's a lot of other values that are also changing when we move the camera. So all the graphics and whatever positions, there's a lot of values. So you move it, change value. You still have a lot of values. So a better way is you might move it, look for a changed value, and then don't move it and look for an unchanged value, because all these red numbers are ones that have changed, but we haven't moved the camera Y, so we're going to look for an unchanged value. Unchanged, and you see it went down quite a bit. And even still, there's values, you just scroll through here, that are turning red, and you can just do that. Next. And it might get tedious clicking this a lot, so there's a little repeat button, and then you can just unchanged, hit next. When this is running, you can do other stuff, like we don't care about the camera X right now, so if we just move it in the camera X direction, you'll see it went down quite a bit as we rotated. So that's pretty good. Now after we do that, we can move the camera Y again, change value, and now we only have 2 values. So which one is it? Well, I just add both of them, hit Control A, and then right click and add selected. And all you want to do is click this button here, and that will freeze the value at negative 0.277 whatever. It'll freeze it there. So now if you move the camera Y, you'll see it pops back. So that's how you know you've found it, is that this value corresponds to the camera Y because it's freezing and it's popping back. This other one is something else. Who knows what it is? But we don't need it, so get rid of it. And then we know this one's called camera Y. And we can also just set it by double clicking on the value here, and you can just set it to 0, and you see that it pops right to it, so we know it's it. And at this point, I like to make a save state, because when you're doing this process of, I usually do a save state before doing anything in here. freezing any values, because when you're doing this process, if you have a big list, if you had a lot of results here and you couldn't narrow them down to just 2, then you would just add them all and then freeze a big chunk of them. Just freeze all of them and then check to see if your CamY is being frozen. And if it's not, you'd get rid of them. But that process of freezing a bunch of stuff and then moving the camera, or just freezing them in general, might crash the game. So instead of having to come back and start the game all over again, just make a save state and then you'll be right back there. And I also like to call this one by whatever save state it's on. So I will just call this F1 CamY, because I put it on F1. Now if I hit F1, it'll load it. Okay, so now we got the CamY, we need the camX. And you can do the same process of doing a new scan, unknown initial value, moving the camera X, looking for a change value. And it'll work pretty quick, but sometimes I just like to also search around the camera Y value, because if it's part of the same camera object, then it should be close. So you can right click on the camera Y and hit browse this memory region, and I'll pull up the memory viewer, and you'll see that when I move the camera Y, all these values are changing, but this is our camera Y value here. It's changing. But if you take a look around here, you might notice that when you move the camera X, this one is also moving. So I'm going to make the assumption that this is the camera X value. Might not always be, but why not? If it saves you some time, then whatever. But to add that one to the list, just put your cursor on the first byte, right click, and hit add this address to the list. We will call it camX, and you have to make sure to F1 camX. Make sure to change the type to, it's also a float. So we added that one, we freeze it, and boom, that's our camera X. So we've got both our values. We're set up, but we need to know where they're at in memory. So just like the serial value, we're going to take each of these values addresses and then minus the start, because that'll give us the offset to the end, or it'll give us the offset to our value. So we do that, not that one. Generally I do this, so the start is at the beginning. So copy the start of the PS2 memory, minus it, and then we know that the camera Y is at this address here. And I generally put the 0x to indicate that it's hexadecimal and indicate that it's an address. Some older stuff might have a little h at the end to distinguish that it's hex, but I use 0x. So I do it for that one, and then copy that address minus the start, and it gives you B8C990999990. So those are the addresses in the PS2 memory. So technically, we could take these and start programming with it. But I happen to know that this game does not have static addresses for these values. So the camera Y and the camera X will not always be at these locations. And we can see that by just restarting the level. We've reloaded the game, so our camera values don't match up. We're going to make a new save state in F2, and you could do the same process of moving the camera, looking for an unchanged value, all that jazz, but instead we're going to go back to our first save state, we're going to look at the camera Y value. We're just going to move it to the top. And you'll see that every time I move it to the top, it always stops at this certain value, 1.5707, whatever. Which happens to be pi divided by 2. So it's just, it's on a radian scale. So we know that's the range up top. And then we go all the way down, and it's the same value but positive. So we know that is the range of the camera Y, and that's how we're going to find it in our other save state. So what I like to do is copy this value and make a little note here of the range. We know that minus that number is up, and the range goes from that to the same number but positive, and that is down. So now let's go back to our other save state and do the same thing. Just look all the way up, and now we can do a scan and just look for that value. And you'll see, bam, right down to 83. Not a lot. And then you can move it and look for a changed value. Boom, there it is. Easy. A lot less steps. We freeze it, move it. We see that that is the camera Y value, CamY. And then we know, whoops, we know that we can just open this up, move the camera X. We know that it's this one. Easy. That is F2 camX. Okay, so now we have our values again. Okay, so how do we find the base? Well, we've got our PS2 memory here. We know somewhere in there is the camera Y value, because we found it twice. One on F1, one on F2. But we know that between those two save states, it's not the same. So it's kind of just moving around in here. So we're going to make the assumption that the camera Y is actually part of a bigger object, which we'll call the camera object. And this object's address in memory we will call the camera base. So that is the start of this object in memory. And when we have that, we're going to assume that the camera Y is the camera base plus some offset. So the offset would be from the start to camera Y. So we're assuming this is this unknown value right here. So we have that. And then we also know that when we reload the game, camera Y moves, but what's actually moving is the camera object is moving. And it's not that it's actually moving, it's actually being deleted, and a new one is being created. So between the two save states, this is where our camera is on F1. We reload the game, and it creates a new one somewhere else. So what we want to find is a pointer to the start of this address. So on F1, we want this address. On F2, we want this address. So we're going to make another assumption that there somewhere in memory is a camera-based pointer whose address does not change. It's static. We don't know the address right now, but the value is the address of the current cam base. So on F1, this would point to this, the start of this object, and then on F2, this would get deleted, and then it would point to this address. So how do we find the address of this supposed cam base pointer? Well, we're going to start a new search. We're going to load our F1 save state. So our camera base is here. And then we're going to do, on the first search, the value would be equal to this cam base. So it's pointing to the start of this object. And then we're going to switch to the F2 save state, this will get deleted, and then this will point here again. So then we know that this address has changed by this amount, which happens to be the difference between the two. So, how do you know this distance? Well, because we don't know the start of this, and we don't know the start of this. What we do know is the start of the CamYs. So we know that, let's get a different color here. We know that the CamY from this cam base is that much, and the camera Y from this base is also that much. It's the same amount. Or that's the assumption we're making. So if those are the same amount, then the distance between the CamYs will be the same as the distance between the camera bases. So we can just use the camera Y to find the camera base, if that makes sense. Okay, let's do it. So we come back to our game. We load save state F1. We do a new scan for an unknown initial value. Make sure it's in X. And then do your first scan. So now our imaginary made up camera base pointer that we think is there should have the address of this camera object as its value. So what we then do is switch to F2, and then we want to search for a value that is changed by the difference between the CamY on F1 and the difference of CamY on F1 and CamY on F2. So you take the larger of the two, which would be F1, minus the address of the second one, and you know that the distance between these two addresses is 8810. So, but the F2 actually has a lower value. So from this, it's actually gone down. So you want to take this and search for, change the scan type to decreased value by, and we know that's decreased by 8810, and we do our next scan. So we found 14 dealies. So at this point, you can look through these. A lot of them are the same. So you see B8, 3EF8 many times. Seems to be the most prominent. And then there's some that are 5A, 6-1. We're going to make another assumption in that the camera Y is a positive offset from the cam base. So it won't be negative. And we're also going to make the assumption that it's pretty close. And what's pretty close? Well, depending on how big the object is, the offset is not going to be too big. In that, like, if this were the base, the offset would be very big. So you would just take camera Y. Oh, this is F2. So you would take this minus this value. Copy. Can you not copy the value? That's quite a ways off. It's almost as big as the address itself. Anyways, it's too big. So it should be close. Within, for some games, I've seen up to like 2500 offset. They can be that high, but generally they will be less than 1000. So it'll be pretty close. So we're going to take all these and add them to the address list. And I'm going to put them in a new group called a cam base pointer. I always put a question mark because I don't know for sure. And then I'm going to always hide manual expand so it's not always huge. But now we can make the assumption that this value right here that these all have is the camera base. So the camera values will be offset from that. So to get their offset, you would take your camera Y, since this is on the F2 save state. So you take your camera Y for this save state minus the supposed camera base to get this offset, 29C. So instead of it being an absolute address, it's actually the cam base plus 29C. And then you can do the same for the camera X. Take the camera X address minus our supposed cam base, you get 288. So then you put that in there too. So technically now we can start programming it in. And we'll do that next. Let's start coding it up. I'm going to be using Visual Code. It's just what I use. And it's got a terminal inside of it. But if you're a new guy, use the stuff I showed you. So you'll be using PowerShell to build it, and you'll Notepad. But to start, we're going to need to come up to the games folder. See this, and you'll see a big stupid list of stuff. They're each just different hacks. You can take a look around. Look at all that stuff. But what you're going to want to do is come up to this blank. This is like a, what do you call that? Template for making a new one. If I remember to put it in there and upload it. So you're going to want to copy that and paste it. So you got a copy now. Close the original. Since this is a PS2 game, you'll notice I have these all prefixed with what system they're on. Some of the original ones don't have them, but go ahead and rename that to a PS2 underscore whatever. Red Fraction 2. Okay, now we got our new file. Now, in here, you need to rename the status and inject functions. You're going to need to put the name into the game driver struct, and you're going to need to create a new one here. So let's do that. For the functions, I also like to prefix it with the system, and then we'll just call it RF2. And now, if you do a new game, you can pretty much call this whatever you want, as long as it does. I think it could be the same name as something else, but yeah, it's static, so it could be the same name, but I don't know. I just put it there. It reminds me what I'm looking at. So you're going to want to put that there, rename it in the game driver struct, rename it in the definition, and the definition for that one as well. And then you're also going to want to put a name in for it. This is just the name that displays while it's running. And then you're going to need to name it when you declare it here. Or define it. Whatever. You can just call this something similar. Red Faction 2. That works. Okay. So, first of all, we need to be able to see that the game is running. And we do that using the status function here. And instead of having this, what we want to do is check for the serial of the game, which is the first thing we did, you remember, from 100 years ago. But you come in here to your serial and then browse in the memory. and we'll see that it's right here. And we're going to just take these first 12 bytes, and we're going to copy them. You can just highlight, Control C, and then I like to not do that. I like to put it in here. But the return function, we have to return whether or not the values in memory are equal to this value right here, because that is the value we're looking for, serial. Do you understand? So the way we do that is there's a function called ps2 mem read word, and the address is going to be, remember at the beginning we said it's at 93390. Here we'll do that just to make sure you understand. So you take that minus the start. This is the address it's at. So we can put that in there as well. So this read word function takes a 32-bit address, so 4 bytes, and the address we want to check is at 93390. We want to see if that is equal to these first 4 bytes. Since that's the start of it, that's the one we want to check. So it's up here. We want to check, so when we say read word, really word here is a 32-bit value. It just happens to be called that, but just remember that. Anyways, so we want to check if these bytes that are read here are equal to that, because that means that these first 4 bytes are equal to SLUS. That's what we want to know. So we say ps2 memory word at 93390, is it equal to this value, not that value, 0x, copy that. No. Here, copy this. We want to make sure it's equal to that value. That's what we're checking. So obviously, that's not going to be enough, because if multiple games store the serial at 93390, then the first 4 ain't going to cut it. You need all of them. You need the rest of it. You need the full serial. So we need to AND this and make another one. Read word 0x9339. Now it's 4 bytes more because we've checked the first part, so we need to add 4 to it and check that that's equal to the next 4 bytes. So now we've got it up to here, 204, and we just need this last bit right here. So you AND it again, ps2 mem read word 0x9339. Now it's plus 4 more, so it's 8 is equal to 0x, and then these last 4 values. And 0x and C is just denoting that it's, once again, that it's hexadecimal. And then you need to put your last dealie. And there we go. Now it'll know that this game is running because it's checking the values in these locations. Understand? And then I also like to put a little comment here of the actual serial value it's looking for. Now, after you've done that, you'll want to come into the games folder again, but game.c, and you'll see another big list of the games, of the game drivers. Ignore this. Ignore that it's already there. But you'll want to copy one of these and add the new game we just added. So it's Red Faction 2 is what we called it. And this will be the name that you gave it here, which could be anything. You can name it balls 3D. And then over here you'd have to put in balls 3D. You get it? So you can name it anything, but it would make sense to name it after the game you're doing. Then come down here. Ignore that's already there, but make another line. Make sure you put a comma, and then just call it the same thing. JK, JK. There you go. Now the game will recognize it. So we build it, and there's an error, red faction 2. What is the problem? Game PS2 red faction 2. Oh, here we go. In our declaration, we forgot to prefix it. So I also do it there. So now they match up everywhere. Now we build it. Bam, and it's built. So now we open up our injector, press 4. You'll see it recognizes, pulls up red faction 2, it locks the mouse, but the camera's not moving. Well, that's because we haven't programmed in any of the addresses, so it doesn't know where any of that is. And it's actually not changing anything, because when it hooks, anything in the inject function is running. So really it's just checking this right now, and this is just checking if the mouse isn't moving at all, and then it's returning. So it's not actually doing any work. So we need to put in the addresses of the camera values that we previously found. Okay, so we can close the injector and go up to the top, and we want to put in our camera base pointer, since it's not, the camera values aren't static, so we need the camera base pointer first, and then we can get the camera base from that. So with these, you can use any of them as long as they don't change over the course of the game. You'd figure that out by playing it a little bit. We still have this thing up. You could do like unchanged, and then click on repeat, and then walk around in the game. Make sure none of them change off of. See, one changed, so you want it to be static. That's the whole point of this thing. This whole process we're doing was that we made an assumption that there was an unchanging pointer to the camera base. So now we've got that. We want to get the address of this camera base. So we copy its address and subtract the start, like we've done many times. And you'll see the address of this pointer is at 334878. So I just note that down. And then we come back in here and we define a variable called rf2 cambase pointer, I like to call it. We know that is at, whoops, cambase pointer at 0x 334878. So we know that's where the pointer is. And then we also want to define the camera X and Y, their offset from the camera base. So rf2 camX we know is equal to the cam base plus 288. So we're going to put 0x288 in there. And then we know the camera Y is equal to 0x29C, I believe it was. Yes, 29C. And then I can make a little line here that says offsets from cam base. Just anything below it. So we know it needs a camera base for these to work. All right. So after you've done that, you can come down here, and we're going to need to get the camera base and from memory, so we can get the camera X and Y values. So you start off by defining a or declaring a camera base, which is going to be a 32-bit unsigned integer. Just call it cam base and set it equals 0 to start with. And down here in the inject function, so this runs every time. This updates while the injector is hooked. So when the injector's on, so right now no inject function is running, but as soon as you hit 4 and it hooks, now it's running this function for whatever game's running. So in this function, we want to set the cam base. We want to get it from the game. So cam base equals, there's another function called PS2 mem read pointer, which will get this address. We know that pointer is at our value that we defined up top, cam base pointer. Okay? So now we can get the camera X and camera Y, which are both floats. So we know we can find those. Camera X equals, there's another function, PS2 mem read float. It's going to read a float from the PS2 memory. And its address is at cam base plus our camX offset, because it's offset from the cam base. And we can do the same for CamY. Just copy the line and change it. So now we've gotten those out. Now, what's the point of all this? Well, you want to add the mouse movement to the camera Y value and camera X value. So when you move the mouse, it changes the camera values. Makes sense. So for camera X, you want to add, so plus equals, you want to take the, well, first of all, we want to define the sensitivity, because that comes from the program also. So you pull it up, you can set the sensitivity, so it should take that into account. You can change it there. So we want to define that, and that's a global variable. So really, wait, what is it called? I don't even know. Look sensitive. Yeah, it's just called sensitivity. Sensitivity equals sensitivity. That's a global variable, but it's an integer, so you're gonna have to cast it to a float. And we'll have to adjust that because it's gonna be way too high. But anyways, now we can take the camX, we can calculate it by adding the X mouse. That's another global variable. You see it's also an integer, so we have to cast it to a float. Plus equals X mouse times look sensitivity. So it'll take the sensitivity into account. For the CamY, it's almost the same, but you'll notice also the injector, you can invert the pitch, so the camera Y value. So we want to take that into account. Otherwise, why is that even there? So easy way to do it, remember you have to cast it, but we're gonna do like a, what's it called, tertiary whatever. Invert pitch is another global that gets set when you change the invert pitch option in the program. So if invert pitch, then you want to take the negative Y mouse. Otherwise, just Y mouse. And then just times look sensitivity. Okay, so now you may think you're done, but really all you've done is copy a value out of the PS2 memory, and you've declared your own variable, and then you've changed that variable. So it hasn't changed the PS2 memory. You have to do that manually. So down here, you do another function called PCSX2, mem write float. So just the opposite of a read float. Instead of reading it, you're writing it. It takes an address, and we want to put, we'll do the cam base or the camX first, which is its address is the same as it is up here. Cam base plus rf2 camX, and then the value is camX, the one that we've calculated right here. We've added the mouse, the change in the mouse to it, so that's the value we want to write back into memory. And then we can do the same for y. CamY. Okay, now we can build it. We go back in here, open it up, turn it on, and we'll see that, Jesus, you want to talk about sensitive. Oh my God. It's a little high, so we need to change that. One thing I like to do is declare a float called scale, just so there's another float, and just, you kind of got to play around with numbers. Let's just do like 10,000 to start. Really, you could like calculate the DPI of your mouse and all this bullshit, but really just any number that feels good when it's at 100% sensitivity in the program. So when this is set to 100%, I feel like my mouse sensitivity is pretty average, so I generally just do what feels good. And you can change the sensitivity, so somebody who doesn't like it could change it, so whatever, dude. No reason to like do all this extra work for whatever. Anyways, you need to take that into account for both calculations. So add the scale, and you want to divide, because obviously you saw the shit was a little insane. So add that, make it again, pull our thing back up, turn it on. There you go. Now we're moving around, and it feels pretty good. Way better than what it is normally. But you'll notice you start moving around, you move the camera up, and it kind of like jitters and down. See, it like pops, and then like you might rotate, and you're like, what the fuck? I can't move it to the right anymore. You turn the other way, you're like, what the fuck is happening? I just feel like crap. You need to go back to Cheat Engine, and you'll see here that when you move the camera around, we already got our CamY range. So for that, we just need to clamp it so it doesn't go beyond that, because when we're moving it with the mouse, if you look at the value over here, you see I move it up, it'll settle back down to its maximum value, but then if you like try to move it beyond it, it actually goes above it, which it normally would not be able to do in the game, because it would internally clamp the value to this range here. So we need to clamp that one, and that's easy to do. Just set our CamY value equal to, there's another function called clamp float, and you just put in the CamY value and then the low and the high of the range. So the low would be negative, even though it's up. Remember, just like the actual numbers, like negative comes first. Negative is lowest, and then the top value. Bam. Just put an F there to show that's a float. So that should work now. But what's going on with the camX value? So you'll notice that now I'm not using the mouse, I'm just turning it with the keyboard. We can spin around, but you have to look at what the X value is doing. You'll see that if I turn to the right, it seems like it sneaks up on like 6 point something. You'll notice it went by pretty quick. We're at 5, bam, 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 and then it wraps past it back to 0. So it's actually going around to 2 pi, aka tau, which is like 6.28 something something. And if you go the other way, it actually goes negative. All the way down to negative 6.2 blah blah blah. Negative tau. So we need to do a similar thing, not quite a clamp, because if you clamped it, you wouldn't be able to go past that value. But we just need to check if it goes over tau, then we want to minus it, because if you know your trigonometry, if you know something about circles, a full circle is 2 pi radians. So anything beyond that is actually, will give you the same angle as, so like 6.3 whatever is the same as 6.3 minus tau. Do you get what I'm saying? It's the same angle, so you just need to minus tau to get, you're doing a whole circle. 2 pi is like 360, so it's like 370 degrees is the same as just 10 degrees. And that's what the game expects to see. So you need to come in here and say if camX is greater than tau, and this is declared up here, so you don't have to type it in. CamX is greater than tau, then camX minus equals tau. So that'll bring it back down to its own scale. The game doesn't know how to handle values greater than 2 pi. Okay? And you might think, yeah, that'll work, but it won't. An if won't work. Because what if you rip the mouse real hard and it like goes up to like 15? Bam. And that's more than tau, and it's more than 2 tau. Because that would be like 12.4, 12.5, 6, whatever. So you'll have the same problem. So you need to do a while statement here, so it can take care of if like you really fucking, you're using your whole desk mouse pad and fucking really, you're really flicking on some dudes in these games that never expected you to do that. So you need to do it in the positive, and since this one also goes the opposite way, it goes down, you need to do it for the negative as well. So if camX is less than negative tau, so the other direction, then you want to add tau. And this should take care of both our problems. I'll bring this up. See, we can move the camera. When we go up to the top, it doesn't jitter. If you can see it, oh, you can. And it doesn't pop past negative 1.57. So it's stable there. And now we can turn the camera. When we get up to 6.28, it flips over. So we're free to move the camera in any direction. So hooray! You might think you're done, but you're actually not. There's a bunch of bullshit that you gotta do, which we'll get into next. Okay, so you've got your camera working. You can move around. I've set the keyboard for all the other keys. You move around. You can shoot. You can fucking, like you're playing Apex Legends now. You're fucking just like flicking on dudes. Feels pretty good, but there's some extra things you gotta do to make it feel a lot better. So first of all, if you pause the game and you move the camera, and you unpause it, you'll notice that it's still moving it. You can turn on your night vision. Anyways, if you pause it, you move it, bam, it moves. Or the menu, It's still moving. So that's another thing you have to take account of. So how do you stop that from happening? Well, you kind of just have to find a value in RAM that is associated with the game pausing. So how do you find that? It's basically the same process as before, except for this one, there's some more assumptions you have to make. First of all, you have to assume the type of value that something like this would be stored in. So generally, if you're looking for something that is it's either on or off, you're either paused or you're not, and that's what we want to find. We want to check if it's paused, and we don't want to move the mouse. We don't want to move the camera if it's paused. So that's what we're going to look for. So something like that would generally be like a boolean value. Cooking up some soup, and so it'd be 0 or 1, true or false, something like that. But you have to make an assumption of how big it would be in memory. So it might take up 4 full bytes. So you had some values here. It might take up 4 full bytes and just be 0 or 1, or it could be a 1 byte value. Generally for PS2, I always start by looking for a 4 byte value, so it'll just be 1 or 0. So, to start, I'm going to assume that when the game is not paused, the value is 0. So we're gonna start by doing that. If it's equal to 0, and then we can do a next scan a couple times. And then I'm gonna pause it. And now I'm going to assume that it's changed to the value 1, because I'm assuming that it's just like a flag, a bool value. So I'm going to set it equal to 1, and we find a couple. We unpause, and now we're going to assume that it's back to 0. And that's still 0, and keep searching. So that's how you would find something like that. Whether or not these are actually the isPaused value for the game is yet to be determined. You have to walk around and change save states and do all sorts of stuff to find out if that's true. And if it's the real true value of isPaused, we don't really care about as long as it's just always true. So I can see that these are actually pretty close. These are kind of close as well in their address. But anyway, so this game's got this pause, but it also has like the menu. So sometimes you can think of it as an isPaused, as in like isPaused. It's like a question for like a bool. If you're making a bool value. But you can think of it as an isPaused value, or for a lot of games I've done, I've just called it isBusy. So if isBusy, then don't move the mouse. So I would call these both pause menus. It technically has 2 different ones. You hit select for like the menu, and then start for this like status menu, whatever. Anyways, right now I'm just going to assume that they're both going to be 1, and we see that a lot of them do change to 1 on both menus. And then you can like click around in the menu, make sure it doesn't change. None of these seem to change. Main menu. See, it goes back to 0. You unpause. So that's good. Another thing you can do is you have to assume or check whether or not these are global variables. So does it translate across like reloads in your save states. So we know the camera Y is not static, but the isPaused flag could be. So I think this is on F2. So we go back to F1. We see that they're all still 0. If we pause, they change to 1. So it seems like it works. And really, you just have to test it. So what I'll do is take all these values, add them to our address list, and put them in their own group. isPaused. Put a question mark, because we really don't know that they work. And then I will get the address for it. Take that minus the start to get our address. And you see that one's pretty low, so I would assume that it will work. It's actually pretty close to this, the camera base pointer. So we'll put that in. Bam. And now we can go back to our C file here, and then we will define another variable up here called rf2 isPaused, and we'll put its address in. And then down here, after this mouse check, before we do anything else, we want to check if it's paused, because if it's paused, then we don't care about the look sensitivity or any of this. Everything after shouldn't be running when it's paused. So we do an if statement, ps2, and this is going to be a unsigned int, so this is a 32-bit. There's also ones for, oh god, no. What the fuck happened? Anyway, there's one for a 16-bit, and there's also an 8-bit. So if you want to read 1 byte or 2 bytes, you got that. So you want to read our isPaused value, and if it's equal to 1, since that's our assumption that we checked, that it's equal to 1 when it's paused and 0 when it's not. Really, you could just do that right there, because in C, a 0 is false and 1, anything else is true. But we'll be transparent here or whatever. So if it's equal to 1, then return. So now we build that, and now it should not move when it's paused, which will make it feel much better. Move it. Moving the camera. It didn't move in the game. Bam. Do the other one. Move it around. Really move it. Did not move. Good. So that's one issue fixed. And we'll move on to the next one. So the next issue we want to look at is pertaining to our camera base. In particular, the pointer. We want to know, does this actually point to a camera base? We want to know when it's not pointing to a camera base. We can see if we quit out to the main menu. When we do so, this gets zeroed out. And then while we're on the main menu, it's still zeroed out. So there's no camera object right now because we don't need one. We're on the menu. So if it's 0, we really don't want to be writing to it, because technically there's no check in here to see if this is a valid pointer or not. And what you would call that sort of check is a sanity check, to see if this value that it was given makes sense. So a real basic one you can do is check that it's not 0. So you can see you can just do if not cambase, then return. So if this is non-zero, then it's good. It'll go through. But if it is 0, this will be true, and then it will return. So that fixes one problem. But in a lot of games, they might share a space here, or it might be what's called a stack value, where flips through a bunch of different values, but depending on what the game's doing, it might have the cam base pointer here at one point, but you walk around the corner and it might change to something else. So in that situation, your mouse would stop working if you don't have a sanity check for it. So there's a couple ways to go about this. The one I'm going to do is we're going to look at the individual bases of a few different save states, and we're just going to pull out some values that match up. So let's do that. Okay, so we're here on our F1 save state. What we want to do is just, instead of having these, we just want to get the start of our object. So we're going to take this and add it to the beginning, just to get the address of our camera base, and I'll just call this F1 cam base since this is the start of the object. We're going to do it for this one, and then we're going to go to F2 and do the same thing. We copy that, add it to the start, and then add that address as F2 cam base. And I always switch this to hexadecimal because you'll see what we're trying to do here. So now I'm going to flip back in between these two, and I'm looking at these values, and they're not the same, but that doesn't mean that some other values around this object are not the same. So what I like to do is kind of move the camera around and then take a screenshot of the memory around the cam base, and I'll go ahead and paste that into Paint. And that's our F1 cam base. And then I will do the same thing for F2. We'll switch to that one. We'll move it around. Take a screenshot. And then we'll paste this in. And what I'm looking for is values that match up between the two objects. We can see these are similar objects. They're in different locations. But you see when I was moving the camera, all this stuff seemed to light up in similar spots. So we know they're similar objects. So what we're going to do is kind of scan through here and try to find values that are the same across both of them. So we start up top. It seems like this value is the same across both of them. This value. And you're really looking for like 4 bytes here. I see that this value is the same. So is this one. Really, you just need a few. We're only going to use like 2 of them for our check, but if you have more, it's helpful because some of these might actually change while you're playing the level. We got this one right here. So just a few. And now what you want to do is go back to our code here. We're going to make a new function. It's going to return uint8t, basically just a bool. We're going to return 0, 1 and call it ps2 rf2 detect cam base. It doesn't take anything. So we're going to declare it up there, define it, and now instead of just setting this value down here, we're going to comment that out, and we're going to do something different in here. So what we're going to start with doing is declaring a temporary cam base, and we're going to set that equal to our ps2 mem read pointer cam base. So we're going to load the CamBase pointer into this value instead, and then we're going to do some checks on it before we set this CamBase value. So what we want to know is first, is it non-zero? So we just check is CamBase, and then we're going to put an and then we want to know, are our sanities the values we think they should be, and are they at the offset that we see? So this first one would be at +8 because it's 8 bytes from the start of the CamBase object, and then this one would be +14 bytes, and so on. So we need to put that into we need to declare that up top as well. So we're going to go back up top, and then we're going to define our sanities. So we call this rf2. It's kind of long-winded, but CamBase pointer sanity 1, and this will be the value we see in here. So we're going to say this is 1, so this value is 19fcFFFF. So we put that in there, 19fcFFFF. And then we're going to do second one, which was all Fs. So that works. 1, 2, 3, 4, 5, 6, 7, 8 Fs. And now, just like these are offset from the CamBase, so are the sanities. So we're going to actually call this sanity 1 value, because that's what it is, and that one as well. So we're going to define rf2 CamBase sanity 1. And we could probably call this just CamBase. It has nothing to do with the pointer. So CamBase sanity 1. This is its offset, and we know it's at 8 bytes from the start. And then we know the second one was at +114. And our thing is still on, so pressing 4 starts it. So it's 1, then 4. So we got that. And these values, like I said, you can just choose any one that matches up. You don't need to know what it does. Some of the other hacks have done, like, they'll check if for like player health, if that's like greater than 0, something like that. But I really just want to know if it is a CamBase object. So you can pick any of them in here. Now we're gonna put that into our program here, into our check. So after we check that the temp CamBase is non-zero, we're going to check that these values are equal to what we think they should be. So we do a read word, because a word will read, or the read word function will check it how it is written right in memory. So it'll read it from left to right. So you do that, and we're going to check the temp CamBase plus our sanity is equal to the sanity value 1. We're going to do the first one, we're going to paste it, get rid of that, and then we're going to do the second one as well. So if those are all true, then we want to set our CamBase equal to our temp CamBase, because we know it's valid, and then we can return 1. And down here, if it gets to the end, we will return 0. So then we can use this instead of doing these lines. We can get rid of that, and then we can just do if not detect CamBase, then return. So now if it's 0, or if it's something that, if it points to something that's not a camera object, and and we're determining that based on our sanity checks, which may or may not be true, so they need to be tested. If all that matches up, then it'll detect the base, and then it'll do like it's normally been doing. So we can build that, and there's a problem. Oh, we have that extra hand at the end. We can build it. Now we go back to our game, and we see that it still works like normal. Go to our other save state, go down the road. We've done many save states. Seems like it always matches up, so we seem good. Okay, so here is the next problem. So your game's working, you're playing it. It seems fine. You're coming around, you're shooting dudes. Shooting guys, blam, 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 blam. It's a lot of fun. But then you start, some shit starts happening. What the hell's going on? Seems like the game has aim punch, and now I'm walking upside down. Now I'm walking backwards. What's the deal? Well, for this game, since it has no aim assist option in the menus, it does have aim assist in the game, but you can't turn it off. So you'll notice every time I can walk at a guy, I can walk towards him, but when I start strafing, it fucks up the camera. So that is the aim assist being added to our aim. And since we're changing the values outside of the game, it doesn't know anything about our changes. So it's adding to a value that it thinks is correct, but it's not. So it results in your aim going all wonky, like that when you strafe, when you're aiming at a guy. So, how do you deal with this? Well, for this game, since it has no option, you can't turn it off. What I would resort to is just making a cheat to disable aim assist. Technically, there could be some option in the game that you could turn off, which might be kind of hard to find, but I think the cheat option, it works, so that's what we're going to do. I've started by calculating our camera X and Y value from our camera-based pointer to start with. You should know how to do that by now. We're going to open up the debugger in PCSX2. You want to make sure this is clicked and you're down at breakpoints. And we're going to right click and create a new breakpoint. And for the address, we want to put in the camera Y value, or the camera Y address. Put that in there, and then we want it to break every time there is a right change. So whenever the value at this address changes, we want it to break. So you got that right, and then you click. And now it seems like it broke right away. It's possible that the value can be written multiple times by different functions. So if you just hit run, you'll see that it seems like every frame it runs, it changes it at this operation here. You can move the camera and hit run. Just hold the stick up, and you'll see that it also moves here. So since that only happens when I move the stick, I would assume that this is adding to the camera Y value whenever you move the joystick. So I would assume it's not to do with our aim assist. So you can unpause, run it. So enable that, and what this stands for is or what it does is it stores a float value to our camera Y address. So what this stands for is store word. So a word is just, in PS2, a word is just 4 bytes from coprocessor 1, which you can find right here. which is the floating point coprocessor. So store this value, F00, foo. Store this value to S0. When you come back to the registers and you see S0 is B7C0A0, which happens to be our camera base. We see that right here. Plus 29C, which is our camera Y offset. So it's putting that value in there. And what I'm going to do is just right click and hit NOP instruction. And that will make it so when it gets to this point, it's no longer storing whatever value it's calculated. So now we hit run and it just runs. Even though we still have our breakpoint set, it's no longer setting that address. It's no longer changing the value there. So now when we run out, we can jump around, shoot guys, and our camera does not freak out. So it seems like that fixed our problem of the aim assist messing with our camera values. You will notice that even though I disabled that, there's still aim assist in the game as when I'm strafing around this guy. It's like spinning me at the same time. So now we have to do the same thing we did for the CamY for the camera X. Okay, now that we've disabled the camera Y aim assist, made a little note of it down here, which operation or op that we've gotten rid of. We need to do the same thing for the camera X. Just because it's not technically needed because it's not breaking the game, but it will make the game feel better to play with the mouse, because generally computer games don't have aim assist. And for this game, it's not too bad. It like kind of sticks to the character. You'll see. So it's like it's kind of helping me out, but it's not like egregious. It's playable, but it would feel better if it had none at all. So that's what we aim to do. So reload our save state. So we want to do the same thing, but with camera X. So we're gonna get the camera X address, make a new breakpoint, and the same thing, a right change at the camera X value, and we run it, and we see that we get one value, this 14D794. So we can do the same thing. We can move the camera X, and we see that when we move it with the controller, this other one comes up, this 14E920. That one comes up. So we can assume that has to do with the just moving the camera normally, not the aim assist. So we unpause it and move it, re-enable our breakpoint. Let's just try nopping this and see if it works. So we do that, we hit run, and now we can move around, and we see another thing pop up. This 170D. We will disable this for now, just so I can illustrate that. One, the aim assist is still enabled. It's kind of hard to get it to go. What you can do is pull up Cheat Engine and look at your camera X value. When you walk by somebody, see, normally if I strafe, it doesn't change at all, which makes sense. But when I walk by a guy, it slightly changes. Sometimes it's hard to tell, depending on how severe it is. But this kind of, you can tell it just like kind of sticks to the guy a little bit when you walk past him. So that obviously is not the operation we want And also, you might notice that this fucker can't turn around now. So we definitely broke something. This guy should be able to turn. He's not a one-dimensional being, so he should be able to turn. So we will load the save state, and you should know that when you load and save states, if you've made any changes in the debugger, like our one operation that we knopped, if you load a save state, it will undo it. So if you want this to persist, you'd have to nop this and then make a save state, and then it will always be there, at least on that save state. If you reload the game, it will undo it as well. So you'll see later that we'll just make a cheat that just writes this constantly, so you don't have to worry about that. Okay, now go back to doing what we were doing. The camX, make sure that's checked. Actually, to find the aim assist value, we are actually going to disable this because it makes it so we can run around without having to like go frame by frame. So the guy can't turn, but if we walk by him, you see even this far away is how big his like aim assist bubble is. But I'm going to assume that this is an aim assist value since it only triggered a change to the camera X when I got near this guy. So I'm going to copy this address and the operation, and then I'm going to label it camX aim assist. But I'm going to nop this one as well, just to see what happens. Just see what happens. You'll see that now. Okay, it happened again. Maybe thought that was it, but apparently there might be two operations that are involved in changing the camX value. So I'm going to copy this one as well. Copy the address, and this is also, I assume, pertaining to the camX aim assist. So I'm going to put it in the same section. We don't need to save anything. But I'm going to nop this as well. So now, when we walk by this guy, it does not appear to be changing our camera X at all. Make sure you walk pretty far away and move. Right now I'm just walking past him and looking at this value to see if it's changing at all. Because sometimes it might still be enabled, but it's like there's like degrees of aim assist depending on your distance from the dude. But it seems like this worked. So what we're gonna do is load our save state. It's going to break because this is still enabled. But so we don't want to nop this one. One we want to nop is actually these addresses here, or at least that's what it seems like. You could do both. It didn't seem to break anything. You'd have to test it to see if it doesn't. But we'll go ahead and we'll try to nop this one since that one seemed to really fix it. So we'll do that one first. So you go over here, right click, jump to, go to address, paste it in, and here's that one operation that we knopped. We're gonna do it again, and then we're gonna run it and see if that turned off the aim assist. And it seemed like it didn't, because it's still, seems like, yeah, it's still moving our camera X. So for this game, it appears that you need to nop both of these to disable the aim assist. So that's what we're gonna do. We're gonna pause it so we don't die. Also, you have to pause it to usually to assemble new instructions, which is the same as nopping. So we're going to do this one as well. Do the same thing. Go to address. Go to that one. This is the other value, or the other operation. We're just going to nop that one as well. And then we can run it. And now it seems like it has totally disabled our aim assist. So there you go. That's how to disable aim assist, or at least one way to do it with cheats. So we've done it in the debugger, but to have it be persistent, it needs to be a cheat. I think technically it could be a patch too. I haven't looked into that. But you want to pull up edit cheats, and you see I've already done this before. So the cheats work. They're in this this format of patch equals 1. I think that's always true. EE is the emotion engine, so it's the processor of the PS2. This is going to be the address. The first 2 bytes dictate how big it is. I don't know. How many bytes it is, or how many something. I don't know. You're just going to use 20 for stuff like this. Extended has to do with some other shit. Just make it always extended. And then the last address is the or the last thing here is the value you want to set it to. So this is going to be the disable aim assist cheat, and you'll see all these addresses here line up with what we found. But yeah, it's going to be like 220 and then this. So and then the values are 0. So normally, let's reload our thing, and let's go to one of these values, or one of these addresses. Whoops. You'll see it's store word. We haven't nopped it yet. So if we go into memory view, you'll see that at 151504, you have these 4 bytes. So this series of bytes is this operation. And you'll see when we nop it, it just all turns to zeros. So zeros are a nop instruction. No instruction. No operation. That's what it stands for, I think. So that's what you want to put as the cheat value. And then there you go. You're done. Your cheat's in. You're cheating. Go to your game properties. Make sure it's enabled. And you're good to go. It should work. More aim assist. Feels better to play. Camera doesn't freak out. Awesome. I think there's one more issue with this game. So take a look at that. Okay, so this is the last thing we're going to look at for this video. It's a very fucking long video. I don't blame you if you didn't make it here, so you won't hear this. But the last thing we need to deal with is you get to about level 3 or 4, can't remember which one it is, and they hit you with this turret section, and it's like an auto scroller. And you'll see we start our injector, and it doesn't work. So generally in these games, like these third-person shooters or first-person shooters, they'll have what I'll call like different game modes. So you'll have like an on-foot section where you're running around. The normal one we've been doing, you're on foot, you're walking around. But then they'll have like a section with a turret. And generally it will have a different base for the turret camera. So the two won't work. Sometimes they line up where they use the same values, but in this case, it doesn't work. So we're going to have to find the camera values for when you're in this stupid turret here. So we're basically going to do the same as we did at the start, looking for the camera Y and camera X values. So we're going to start a scan, unknown value, and then we're going to move the camera Y a little bit, look for a changed value, and do the same thing we did at the beginning. Look for a changed value, maybe look for an unchanged, spin the camera, look for another changed one. Okay, there we go. Narrowed it down pretty quick, right to 1. And we can see that is the value we're looking for. So we will call this, it's on like F8, turret X. Just gonna, or not turret X, turret Y. So we're gonna do the same thing as we did on the first one. We're just gonna open up the memory around it. We're gonna look at it. That's camera Y right here. If we move the X, we see that this one changes. These change too, but they zero out. So I assume that's like having to do with either the speed or like maybe the analog stick position. So I'm gonna guess that this one is camera X, and we're just gonna add that as a float. We're gonna freeze it and try to move it. There you go. That is the turret X. And then now we want to check if this is static or not. Like, is the turret X and Y, are they always in these locations or not? So we can do the same as we did at the beginning and try restarting the level. Fast forward through this. We get back in here and we move the turret around and we see that it actually is static. So we might not have to find a base for this one. So we're just going to get the values here, or the addresses. This one seems pretty high, so it may or may not be static. One way you could check is if you kind of just have to play the game more. I haven't played this game all the way through, so I'm not sure if there's another turret section. What you would want to do is get to that section and see if these values are still being used, these addresses. I do know the beginning of the game, if you remember, had a weird section where right when you start it, there's a section where the camera doesn't work, but normally you can move the camera. So it's this section right here. See, the camera doesn't work, but you'll see that the values actually do change. So if you freeze these and move them, you'll see that this uses the same camera values. So technically it is also like what we're calling the turret. It just uses the same values as it does here. So what we're going to do is actually make a save state at that section. Fast forward through here. It's pretty short, so it might be kind of annoying to use. But we're going to save it on slot 7. Because we want to know when this camera is being used. So we're going to look for a flag that is like is turret camera or like is cinematic camera, something like that. I'm just going to call it turret because it seems like I don't know how many times in the game it uses this. So for now, this seems like a pretty long level, this turret section, so we're just going to call it that. So what we're going to do is search for another 4-byte flag, and again we're going to assume that if it is a cinematic camera, we're going to assume that the value is going to be 1. This is the first test we're going to do. We're just going to assume that right now the value is 1. And then since our on F7 it also uses the same addresses, we're going to assume it's still 1 here. So you can run both of those a little bit. Go back to this one. Do like repeating unchanged value. Move the camera around. Destroy some stuff. Pause it. Do whatever. It doesn't seem to be going down too fast, but we will switch to another level, and we're going to assume here in the like an on foot section that it is 0. So it is not a like turret section, or not like an auto scroller section or whatever. So we're going to kind of just shoot, run around here, just get rid of some of these values that might change in gameplay. You might only get rid of a few at a time, or none. But you just kind of got to move around and do something like that. Another thing we can do is this game also has multiplayer. So I would assume in multiplayer that it is also the same, to where it is not a like a turret auto scroller camera thingy. So we get into the multiplayer, and you can see this works. It won't always work in multiplayer, these same like bases and whatnot, but we're gonna assume that it is also 0 here. So now we can do like an unchanged value, and then we can move around a bit, shoot some guys. Maybe try to die, see if that changes. Okay, see, we're getting rid of a few. We just want to get rid of as many as possible, so our like a list of values is smaller. Because you might use one of these values. The reason I save like a bunch of them, like we've done with the camera base pointer, like we still have all of these. The reason I do that is if later I find out that like this address, this value won't always work, then I try one of the other ones. So saves me from having to go back and like do this same check. So then I could just like go to the next one, see if that works. If it doesn't, go to the next one, and so on. But anyways, it seemed to have narrowed this down pretty far. And I'm just going to choose one of these values and see if it works. So I'm going to save all of them, and I'm going to put them in their own group called isTurret is fine with a question mark. And then I want to make it so they're not always expanded. But I'm just going to take the first one. And it's going to require you to test it to see if it works. Because you might find that you play it through a bit and it works, but then maybe you reset the game, and if you go to a level from the start, the value might not be 0 on the on-foot sections. So obviously that would not work for our test. So we're going to save this. And you can see it's pretty low. It's pretty close to our camera-based pointer, actually. So it's possible that it is this sort of flag we're talking about. But we're going to take that. We're going to shut these guys up. We're going to go back here. We're going to define an RF2 is turret. We're going to put our value in there. And then we also need our turret values. So let's see, these right here. Our turret Y is that. So we're going to put define RF2 turret Y, and then our turret X was I think just add 4, yeah. So C, and now with this this information, what we can do is come back down to the inject function. First of all, we're going to move this. Now we're going to keep that there. But then we're going to do a check. We're going to check that value to see if it is a turret. So we're just going to check a unsigned int. And it's the isTurret value. So if it is turret, then we will update the turret camera values. Otherwise, so else, we're going to do what we've been doing this whole time, and that's do the on-foot camera. So we're going to declare a float, turret X equals read float at turret X, since it's just like an absolute address. It seems like it's always there. Once again, you have to test this, so it's not for certain until you've played the game all the way through that you know for sure. But we're gonna do the same calculations that we did. We're gonna add the X mouse times the look sensitivity divided by scale, and then we can really just copy and paste this. Maybe except for the cam float, and we don't know if that's true either. So maybe we won't copy and paste it. We'll add the turret Y is plus equals float of remember we do like a ternary operator, invert pitch. If that's true, then take the negative Y mouse, otherwise the Y mouse, times look sensitivity divided by scale. So it does the same thing. And then we will do a PS2 mem right float at turret X, the address, and then the float value. So I'll change that to Y, that to Y, and now this should work for our turret section and for the first part. So you see it does work. It's actually backwards on both axes, so we just need to minus both of these and then build it again, and then now we can move it. Finally it's working again. We need to check that watching my X value here, we might have the same problem as we did before, and actually does not seem to have it. This one seems like it wraps fine. You might find that sometimes you have to put that check in there anyways. I'm talking about this one right here. If it's greater than like one full rotation, then you might have to check, because if like right when you get to that wrapping point for here, it's like this direction. If you're like right on there, it might do some weird stuff, but this seems like it works. We'll say the only problem with this, which I'm probably not going to get into because it's not that big of a deal, but it has the problem of the clamping. But if you clamp this one, then this one will not work the same. So it's like in this one, you actually can't rotate past that far. That's your range. So if you really want this to be perfect, then you would have to do a check to see if it is a turret camera, turret in quotes. So if it's this or this, and then you'd have to check for a value that is true here, but false here. You get what I'm saying? So if it is a turret, but it's this like cinematic one, and you're not actually in the turret, or what we're calling the turret cam. Do you understand? Good. Okay, so that's that, and then that's everything. So that's gonna be the end of the video. It's been like 2 fucking hours, I think. And that's pretty much the whole process. And there might be some stuff I left out. Whoa! Stop right there, buddy. I'm from the future. I'm here to tell you something that fucking moron forgot to. So you're working on your game. Everything's going good. But then you close the emulator. Bam. Now all your things don't line up. You open it back up. Start your game again. You get back in the game. And question marks? What the fuck does that mean? Well, come back in here. Open your process again. You're going to want to click yes here. Otherwise, it'll get rid of all this. And if you haven't saved it, it'll fuck you. But you see, you open it and it's still all question marks. How do you fix this? Well, like I was saying earlier, the PS2 RAM will move around in the program. So what you need to do is recalculate the addresses for all these. And how do you do that? Well, you come up here, you click this all right here, and then click all again. It'll change back to searching all of the memory. But then you need to search for your serial again. So you bring it up here. It was already in there. It's going to search. You got to wait. But then it'll come back up. So remember, we always use this first one, and we're using this 93390. So select this, and then click on the one in your address list, and hit Control A. And I'll select them all. Then you want to right click on it and come to recalculate new addresses. When this little thing pops up, it'll say change by offset. So it'll move all our addresses to where they should be. And you want to click hexadecimal as well. And then hit change. And boom, all your things line up again. And you're ready to keep it on. Okay, that's it. Sure there is. There's a lot of little like small tidbits and stuff that could help you. But I think that's enough to get you started into making one of these hacks. You can it's a good way to get into like just game hacking in general, I think. And you can really do anything with the mouse injector. Like, it doesn't have to be like first-person shooters, third-person shooters, whatever. You can control anything with the mouse if you want. You can control like a guy's X and Y position if you want, and whatever. I don't know. I've done that for like I think, what was it, Raiden 3 or something? Some shoot 'em up on the Super Nintendo. I made it so you can move with the mouse. I can't remember which one it was. You could do that. You could do whatever. But if you understand all these concepts, then really you could get into just general game hacking. Now you understand the concepts to do like translation hacks or whatever. You can just start messing around. You can start messing with values in here. You can look for like jump velocities, speeds. You can start messing with like enemy behavior, enemy health and shit. You can make the game much harder or whatever you want to do, which I think would be cool for a lot of these mouse injector hacks, because generally if you're playing with the mouse, it makes the game much easier, and usually like trivializes the game. Some of them are still kind of hard. I think like Dark Watch is still pretty fucking hard, even with the mouse, just because like the hitboxes. But yeah, you can do all that sorts of stuff. And if you have any comments, questions, please leave them in the bottom. If you ask a question that I answer in the video, I probably won't answer it. You're going to have to watch the entire 2-hour video. I'm sorry. But somebody else in the comments might answer it for you. So, yeah. Try this out. It's pretty fun. Peek the mic. And see you later. Goodbye.